We often picture black holes as giant space vacuums violently sucking in everything around them, or as massive, solid walls of darkness floating in the galaxy. There is also a popular idea that if you fell into one, time dilation would essentially turn you into a time traveler, allowing you to watch the rest of the universe age and fast forward before you die. But gravity does not work quite like that. A journey into a black hole splits into two completely different realities. An astronomer watching you from a safe distance sees one sequence of events, while you, the falling astronaut, experience something entirely different. To understand what you would actually see through your visor, we have to rely on the math of general relativity. Albert Einstein's equations map out exactly how extreme gravity warps the behavior of light and the flow of time. So let's leave the outside observer behind. Imagine you are in the spacesuit, actively descending toward the center. What do you actually see when the normal rules of light begin to break down? The true terror of a black hole lies in how gravity systematically dismantles your physical reality, warping light and time step by step as you fall deep into the void. At first, your initial approach is completely smooth. As you glide toward the event horizon, you don't feel any physical resistance or drag pulling at your ship. But the space around you is warping. The sheer mass of the black hole creates an effect called gravitational lensing. It acts like a colossal, distorted magnifying glass, grabbing the light from stars located far behind the black hole and bending those beams around its edges. Those background stars are stretched out, their light merging to form what astrophysicists call an Einstein ring, a bright, glowing halo of starlight encircling a sphere of pure darkness. As you continue closer, that darkness begins to swallow your forward view. This is the visual horizon. The black sphere expands outward until it completely wraps around your peripheral vision. You are gliding through an empty vacuum, but the architecture of space itself is curving to trap your eyes in a tunnel of shadow. Eventually, you cross the event horizon. There is no physical barrier, no sudden jolt, no sirens, and no flashing lights. If you weren't checking your instruments, you wouldn't feel the crossing at all. Physically, the crossing is smooth. Visually, your reality flips. Inside the horizon, gravity is so intense that light is forced to travel exclusively inward. No photons can bounce back up toward your eyes. If you look straight ahead, you see pure black. To see anything at all, you have to look over your shoulder, back toward the universe you left behind, where starlight is still falling in with you. The entire night sky is compressed. The panoramic view of the cosmos shrinks down into a blindingly bright window directly above your head. That window is constantly changing color because of gravitational blue shift. As light from the outside universe falls into the black hole, gravity accelerates and highly compresses the light waves. The wider waves of red and yellow light are squeezed tightly together, shifting them into a brilliant blue. That compression accelerates. The light shifts from blue to violet, and then the waves become so tightly packed that they leave the visible spectrum entirely, turning into invisible ultraviolet radiation and X-rays. You pass smoothly through empty space, while the optical threshold violently compresses the universe behind you into a radioactive pinpoint. This brings us to that popular idea about time, the myth that looking back through that window lets you watch the entire future history of the cosmos play out. It is true that if someone were watching you fall, they would see your clock slow down until it practically stopped. But inside your suit, your local time ticks away normally. You are actively accelerating downward. The light rays carrying images of the future universe are pouring in from behind, but they have to catch up to your rapid descent. Because you are falling away from the incoming light, you only intersect with those beams for a short time. You see the outside world speed up slightly, but you hit the center long before the universe ends. The math denies you a glimpse of eternity. You are locked squarely into your own rapidly expiring timeline. Deep inside the event horizon, general relativity reveals a final terrifying twist. Space and time swap roles. Moving downward toward the center is no longer a spatial direction. In the warped geometry of a black hole, moving downward becomes structurally identical to moving forward in time. You can no more steer away from the center of the black hole than you can stop yourself from moving into tomorrow morning. As that inevitable future approaches, extreme spaghettification takes over. The gravitational pull on your feet becomes vastly stronger than the pull on your head. You are violently stretched vertically and squeezed horizontally. The singularity is a mandatory moment in your immediate future, where your physical structure is stretched past its breaking point. In those final milliseconds, the blue-shifted window of the outside cosmos narrows down to a single brilliant speck of light. And then there is absolute darkness. That final, highly compressed pinpoint of the outside universe simply blinks out, leaving nothing behind. At this exact stage, the tidal forces dominate everything. The eyes you were using to look back, and the brain processing those images, are dismantled into their constituent atoms at the singularity. A black hole acts as an active cosmic eraser. It tears apart light, stretches the geometry of space, and breaks the progression of time, dismantling our entire perception of reality long before it breaks us physically.